Welcome to video 21 of the Discrete Math video series. In this video, we'll discuss the solutions to the two problems introduced in the previous video. To find a proposition that is true under these conditions, we can simply assert P, because we want it to be true when P is true, assert Q, and assert the negation of R, because we want it to be true when R is false. And then you can check that if you make any other assignment to the truth value or to the variables, then this sentence would come out false. So there's the solution. Next, to assert that every cell of a 9 by 9 Sudoku has a number from 1 to 9, we need to have like some way of writing down the propositions that somehow communicate this. So we're going to use a system where P propositions will, in a sense, be indexed by IJN, right? So P of IJN will mean that at row I, column J, this cell, right, the cell at row I and column J contains the number n. So for example, if we wrote down P paren 1, 2, 3, what does that mean? It means that at row 1 and column 2, the number 3 occurs in that cell. And so with this naming system for our propositions, then we simply want to say that like whatever I and J are, what occurs in that cell is some number from 1 to 9. So we're going to write a big disjunction saying that it could be 1, or it could be 2, or it could be 3, or so on up to 9. Now that disjunction, so to speak, ranges over the variable n. We also want to say that this occurs at every row and column. So we also want conjunctions asserting this at every single row and column where the row index goes 1 to 9 and the column index also goes from 1 to 9. So that's a big conjunction which says that for every row and for every column, right? Every being somewhat sort of synonymous with doing a big conjunction over all of these possibilities. At every one of those choices of row and column, what we said earlier applies.